Hello student, very good morning to all of you. I hope you all are happy, healthy and fine at home. What did we discuss yesterday or so far? So whatever we have discussed so far, let us revise those terms, those terminologies, what is actually it means in short form, that we are going to learn actual concept of this, and there, that's why I am giving here is a summary whatever we have seen in the B point, that all are the theoretical part as well as how the carbohydrate type symmetry is present over there, how the target molecule and the chiral precursor, what are there, how the sense of chirality is applied there, stereochemical control, stereo selective, why should be the chiral, how it is actually means that is a chiral template, what does it mean, or what is the actual definition, theoretical definition. So it is written here, chiral template, the carbon framework which are an exact copy of the segment of the target and have its inherent natural chirality which can be related to original stereochemical part of target are called as chiral template. So this is the definition for that, and here is an example. One example is sufficient. What is Chiral approach, what is a chiral template, at that moment you must remember such type of the short things are there. Let us see, here is a one general example is given, that is a target molecule, it containing as a five membered, has a furan type, tetrahydrofuran type of the structures are there, that may be as attached to some bases, and as we know that in a carbohydrate nucleic acids are there are some bases are there, how it is attached, and now this target molecule could be made from this chiron, and as we know that chiron means what, that is another definition we are going to leave, and there is a chiral template, means that chiral template is nothing but as a chiral precursor. Remember here, chiral template is nothing but as a chiral precursor. By using this, which is readily, and their availability and the cost depending upon that, and as we know that carbohydrates are readily available in the nature, we can use it. Cost is no doubt in that is readily available, we can use as a starting material, and we can prepare many of the natural products and which is useful or which act as a drug, or what we can call it is a medicinal property they exhibit or they show, and that's why this is the chiral template. Understood this one, carbon framework are there. Then chirons means what, actual definition of the chiron is there. These are the retrosynthetically, have you heard this word, retrosynthetically generated by minimum deviation of a chiral center in the target molecule is known as a chiron. And before that, let us see this chiral template in a simplified way. Let us see that how this is nicely depicted in the diagram. Let us see here, suppose we have this type of the target molecule. Let us simplify this one. This is a target molecule. Suppose you assume that this is your target molecule, right? This is the target molecule over here. This is a target molecule. You can remember, not this one, you remember this is your target molecule. This is your target molecule, where this portion I am shading over here, and now another portion is here like this. This is our target molecule. By joining that template we get chiron, and look at here, after this is a disconnection arrow, and as we know that disconnection means what, in the retrosynthesis we are using as these terms are there. Target molecule means what, target molecule means the molecule whose synthesis being planned is called as a target molecule. In the retrosynthesis we are using as a sum of the term, like as first one, suppose as a retrosynthetic analysis. second will be as a retrosynthesis, third one may be as a what we can call it as a disconnection, fourth one may be as a synthon, fifth one may be as a synthetic equivalent, sixth one may be I think what is that, R means reagent, and seventh one may be as a what is that, synthon, synthetic equivalent, reagent, and the FGI, functional group interconversion. 1, 2, 3, 4, 5, 6 and 7. These are the term generally we are using while studying as a retrosynthetic analysis. That retrosynthetic analysis is different than this one. In this particular, we are approaching the perspective of this retrosynthesis should be keeping in mind there must be as a chiron, and as we know that chiron means what, these are the retrosynthetically generated by minimum deviation of chiral center in the target molecule, and as we know that chiral carbon means what, the carbon atom attached to 4 different group is known as a chiral, and known as a chiral carbon, and that molecule becomes as a chiral. That shows the property that is the optical activity, and as we know that optical activity means what, the certain substance rotate the plane of polarization through certain angle is known as optical activity. It is one of the physical property of the organic compound, and the instrument used to measure the optical activity is the polarimeter. Polarimeter is the instrument used to measure the optical activity of this, and that is, suppose here is in a retrosynthesis we are using RSA, retrosynthetic analysis. Retrosynthetic analysis means what, the process of breaking down the target molecule into convenient starting material by using disconnection and FGI is known as a retrosynthetic analysis, right? This is and retrosynthesis means what? Retrosynthesis means what? An imaginary but logical reverse chemical reaction which helps us to reach the reactant starting from the target molecule is known as a retrosynthesis, or it is the art of that is planning the synthesis is called as. Then I think 8 number here may be as a 8 one TM. We forgotten that TM is target molecule. Just now we have seen target molecule means what, the molecule whose synthesis being planned is called as a target molecule, and now is a disconnection. Disconnection means it is a very important step in the retrosynthetic analysis. In this we are going to use as a retrosynthetic approach, retrosynthesis, but via Chiron approach. We are not going to go anywhere randomly. We are fixing our route. We are using as a Chiron approach as a route to reach to the target molecule. And disconnection, as we know that disconnection means what, it is an analytical operation of breaking the bond and converting the target molecule into a possible starting material is known as a disconnection. And synthon, as we know that in the synthon, in a retrosynthetic analysis we frequently using these are the terms. Synthon means what, it is associated with the polarities, means after breaking as a bond, carbon-carbon bond, either on one side we are getting maybe as a positive or negative, that type of the species are called as a synthon. And then synthetic equivalent means what, synthetic equivalent, these synthon are associated with polarities, and synthetic equivalent, the reagent carrying out the function of synthon is called as a synthetic equivalent. And there is a reagent, and everybody knows as we are referring this word from 11th standard, reagent. What does it mean? Reagent means what, a compound which react to give an intermediate or target molecule itself is known as a reagent. And then FGI means functional group interconversion. In that case we are converting here also by using as a Chiron approach. The functional group interconversion means what? The one of the functional group is converted into another functional group, so that this connection become possible is known as a FGI. And target molecule, just now we have seen, this is a target molecule here, and that target molecule is nothing but whose synthesis being planned is called as a target molecule. Now we are showing here the pictorial representation of this chiral template. This is a target molecule. Now look at this portion I am showing here. This portion, shaded portion I am showing here. This is one of the what we can call it as a, here I am also showing this portion only. Here you can join here. This is a portion I am showing, shaded portion only. Look at here, whatever target molecule, shaded portion over here, this is a target molecule 1, 2, 3, there is a vacant, right? Only shaded portion 1 and 2 portion I am shading over here, and this shaded portion here shown means whatever segment, this segment is actually present in the target molecule, retrosynthetic. This is a disconnection arrow, and this portion is known as a Chiron. Understood this? And this Chiron word is coming from the chiral as well as synthon, which is the term used in a retrosynthesis. This is called as a Chiron. Understood? In the previous we have seen actual example, but here this is a Chiron, means shaded portion only, or you can show unshaded portion also, that is also as a Chiron. But this shaded, that is apparent, whatever segments are there, it is exactly same of this. And now this can be shown with the help of this another term, like you can show this one maybe as a this one shaded portion, or you can show this way shaded portion, right? From these two parts are there. From this we can make as a two part over here, two part you can shade like this, or maybe another way to represent this one. And these are called as a chiral template. These are called as a chiral template. Understood the meaning of that chiral template? Chiral template means by joining properly, and we can make this type of the chirons are there. And once you got chiron, we can easily convert that chiron into as a target molecule. This is a simple representation of the how we can make the chiral molecule, or how we can make the chiral molecule by through via chiron. Chiron is the intermediate, and the chiral template, these are the chiral precursor. These nothing but, and whatever geometries are there that having target molecule, that geometry we can modify. There are the different method we have seen how to modify their carbon framework, how we can arrive, how we can prepare as a chiron. And once you get the chiron, you can easily get the target molecule in that case. And how the use of rule of 5 is applied over there, the position of a ring oxygen and anomeric carbon in a hexapyronis derivative are 5 atom or bond away. This is called the rule of 5 that we already seen. The rule is applicable for a large number of syntheses involving carbohydrate as their precursor, that is a starting material. And the relationship here heteroatom to the anomeric carbon is important, and locating or finding the carbohydrate position in a target molecule. Then chiral rule strategy, how we can make the strategy to arrive to obtain the target molecule. It involves the examination of molecular structure of given target to locate the element of symmetry, then locate the chirality, and then locate the functionality, because that functionality we can get in a proper way by controlling as a steric control or stereo selection, decoding of such information, that is transpose it into carbon framework of the suitable synthetic precursor chiron, which is in turn are obtained from chiral starting material, that is a chiral template, by synthetic functionalization. So that is all these about that. Now the advantage of Chiron approach over the retrosynthetic approach, that we are going to highlight over here, we are going to discuss here. Let us see here. Chiral approach, the synthetic equivalent are ideal naturally occurring organic compound. It directly given access for synthesis of natural product, right? So this is one of the main advantage of this Chiron retrosynthetic analysis over the normal retrosynthesis. The chiral precursor in starting material is active intermediate, which can be easily used for synthesis of different target molecules having chiral centers. Without chiral center we cannot, but your starting compound should have a chiral center, and this chiron having chiral center with either R or S, as we know that R or S configuration, and the fourth chiral precursor can be utilized in the synthesis of natural product such as biotin, and biotin we already learned how we can synthesize that biotin starting from the chiral precursors. So I think with this we have completed this B point. So tomorrow we will see the next one, very important one. What is that one? Actually there are the 6 molecules are there and that we are going to learn utilization of chiral template and utilization of the basic concept in synthesis of we are going to learn. There are the 6 molecules are there, natural molecules we are going to actually synthesize by keeping the Chiron approach here, whatever we have seen so far. So we are actually going to apply there, and we will synthesize propylene diol, propylene diol, then R and S, epichlorohydrin, L plus alanine, then minus multistratin, minus pentomycin, and minus shikimic acid. These are the 6 molecules. From tomorrow we will see. Let us stop today here. Have a nice day. Thank you.